How much do we really know about our star? How do we see it? What does it look like? And what does it look like right now? Hello and welcome to Curiosity, where we explore fascinating and interesting topics about everything. Today we are going to talk about one of the most important things in our lives, the sun. The sun is our star, our source of energy and warmth, our clock and calendar, our inspiration and wonder. Without the sun, life on Earth would not exist. Let me ask you a question. How long does it take for sunlight to reach our planet? Is it a matter of seconds? Minutes? Hours? Take a moment to think about it and write your answer in the comments below. The answer might surprise you. It takes sunlight an average of 8 minutes and 20 seconds to travel from the sun to the Earth. That means that when we look at our star in the sky, we are actually seeing how it was 8 minutes and 20 seconds ago. We are looking at its past image, not its present one. But why does it take so long for sunlight to reach us? Well, it's because of two factors, distance and speed. First of all, distance. The sun is very far away from us. The average distance between our planet and our star is about 150 million kilometers. That's equivalent to about 100 times the circumference of our planet. Imagine how long it would take you to walk or drive that distance. To put this into perspective, let's compare this distance with some other distances in our solar system. For example, if you could fly from Earth to Mars at a constant speed of 1,000 kilometers per hour, which is faster than any airplane, it would take you more than 5 months to get there. But if you could fly from Earth to Sun at that same speed, which would be impossible, it would take you more than 17 years. Secondly, speed. Light travels very fast indeed. Light is actually the fastest thing in existence as far as we know. And nothing can go faster than light according to our current understanding of physics. The speed of light is about 300,000 kilometers per second. That's equivalent to about 7.5 times around our planet in 1 second. Imagine how fast that is. But even at that incredible speed, which no human-made object can ever achieve, light still takes time to travel across space, which is mostly empty. And because our planet orbits our star in an elliptical shape, not a perfect circle, sometimes we are closer or farther away from our star than usual by a few million kilometers. That means that sometimes sunlight takes a little bit more or less time to reach us than average by a few seconds. At its closest point, which is called perihelion, sunlight only takes 490 seconds or about 8 minutes and 10 seconds to reach Earth. And then at its most distant point, which is called aphelion, sunlight takes 507 seconds or about 8 minutes and 27 seconds for sunlight to make its journey. So what does this mean for us? Well, it means that we can never see our star as it really is right now unless we somehow manage to travel there. We can only see how it was a few minutes ago depending on where we are in our orbit. And this applies not only to our star but also everything else in space. The moon and other planets reflecting sunlight, stars emitting their own light, galaxies containing billions of stars, etc. Think about the common night sky as follows. When we look at our moon which orbits around us, we are seeing how it was about 1.3 seconds ago. That's not a big difference because our moon is relatively close but still noticeable if you pay attention. When we look at Mars, which is the fourth planet from our star, we are seeing how it was between 4 and 24 minutes ago depending on where both planets are in their orbits around our star. Sometimes they are closer or farther away from each other. That's a significant difference because Mars is much farther away than our moon. When we look at Proxima Centauri, which is the nearest star other than ours, we are seeing how it was about 4 years ago. That's because Proxima Centauri is so far away from us that light takes 4 years to travel from there to here, even though Proxima Centauri is relatively close compared with other stars. When we look at some of the stars that we see in the night sky with our naked eyes, we are seeing how they were hundreds, thousands, or even millions of years ago. That's because some of those stars are so far away from us that light takes a very long time to travel from there to here, even though those stars are relatively close compared with other galaxies. And when we look at some of the galaxies that we see with telescopes, we are seeing how they were billions of years ago. That's because some of the galaxies that we see with telescopes are so far away from us that light takes billions of years to travel from there to here, even though those galaxies are relatively close compared with the edge of the observable universe. So what does this tell us? It tells us that space is huge and time is relative. It tells us that we are not only living in a place but also in a moment. It tells us that we are not only observing but also participating in the history of the cosmos. It tells us that we are not only curious but also humble. Because when we look at the sun or any other object in space, we are not just seeing them as they are. We are seeing them as they were. We are seeing their past selves, not their present ones. And we can never know for sure what they look like right now, unless we somehow manage to travel there faster than light, which seems impossible according to our current understanding of physics. But maybe that's okay. Maybe that's part of the beauty and mystery of the universe. Maybe that's what makes us curious and wonder. Maybe that's what makes us appreciate and cherish the present moment more. So next time you look up at the sky, remember that you are looking at a time machine. You are seeing how things were in the past, not how they are now. And who knows what they might look like in the future. That's all for today's episode. Thank you for watching Curiosity. If you enjoyed this video, please like and subscribe for more content like this. And don't forget to share your thoughts and questions in the comments below. Until next time, stay curious,